Hi, STEM stars. Welcome back. No matter where you are or what you're doing, changes are happening all around you. Plants grow, logs burn, and your lunch disappears bite by bite. All these everyday changes involve matter, changing in size, shape, or structure, absorbing or releasing energy, and sometimes even turning into something entirely new. In chemistry, we group these changes into two main types: physical changes and chemical changes. In the previous lesson, we have discussed about physical changes. Let's see how chemical changes are different from physical changes and how can you identify them. What is a chemical change? A chemical change happens when substances mix or break apart to form new substances with different properties. It's like a science magic trick. Ready to learn more? Let's go. Okay, let's look at some chemical changes you see every day. First, think about cooking. When you bake a cake, the batter turns into a fluffy cake. You can't turn it back into batter, right? That's a chemical change. The ingredients react to form something new.
Another example is rusting. If you leave a bike outside in the rain, it might get rusty. The iron in the bike reacts with oxygen and water to form rust, a totally new substance.
And how about digestion? When you eat a burger, your stomach breaks it down into nutrients. That's a chemical change happening inside you. Cool, huh? Can you think of another example? Pause the video and write an example in comments.
When you burn wood, it turns into a new substance, ash, no longer wood. You'll also notice smoke, heat, and light. These are strong clues that a chemical reaction has occurred.
So, how do we know a chemical change is happening? Scientists look for clues. Here are 5 big ones. Number 1, color change. When an apple turns brown after you cut it, that's a chemical change. The apple reacts with oxygen in the air. Hair bleaches contain hydrogen peroxide that reacts with the natural pigments in hair and decolor them. Number 2, gas production. Ever mix baking soda and vinegar? It fizzes and makes bubbles. Those bubbles are carbon dioxide gas, a sign of a chemical change. Baking bread, yeast ferments sugars, producing carbon dioxide that makes the dough rise. Number 3, temperature change. When a fire burns, it gets hot. That heat comes from a chemical reaction. When we boil an egg, heat is absorbed to denature proteins and cook the egg. Number 4, new substance formed. Think of burning paper. It turns into ash, which is totally different from paper. During photosynthesis, green plants use sunlight to convert carbon dioxide and water into glucose and oxygen. It is a chemical change because new substances are formed, and the process cannot be reversed. Number 5, lighter sound. Fireworks explode with bright light and loud bangs. Definitely a chemical change. These clues help us spot chemical changes. Want to be a science detective? Look for these signs around you. Now let's clear up something important. Chemical changes are different from physical changes. A physical change only changes how something looks or its state, but it's still the same substance. For example, if you tear a piece of paper, it's still paper, just smaller. Or when ice melts into water, it's still H2O. But a chemical change creates a new substance. Remember burning paper? It turns into ash, which isn't paper anymore. Here's a quick trick. If you can't undo it easily, it's probably a chemical change. You can refreeze water, but you can't unburn paper. Got it? Let's test it. Is autumn leaf color a chemical change or a physical change? It is a chemical change because the green pigment chlorophyll breaks down. The color change is irreversible, a key sign of a chemical change. Wow, we've learned so much about chemical changes. Thanks for joining on this science adventure. See you next time.